All right, so recap on assemblies. Anyone want to try and do their best to explain what an assembly is in SolidWorks? Sure, yeah, it's an assembly of multiple parts, combination of multiple parts. Again, if I use my analogy, it's kind of like an InDesign file where you're placing photos inside of it. So it's like the assembly is the InDesign file, the parts are the photos. An assembly itself is actually not anything. It's just pointing to a bunch of parts and organizing them in a way that they relate to each other. And again, just like with SolidWorks, there's a lot of the parts have relationships to each other. It's how you tell them where to be, where to go. So last time we put this handle in, you can see with my mate here, the relationship, the rule that I told these two parts to have to each other. Well, so first, I guess let me back up. The first part I put in here is this microwave body. And my microwave is attached, the front face on the body is attached to the front face in the assembly, and all those planes match up. So that's the first part I put in there. The next part I put in is the handle. The only relationship that the handle has to the microwave is I said, hey, I want this face here to be coincident to this face. I want them to be touching and stick to each other. And you can see that like that's not it's not fully defined. Just like a sketch that's blue, this handle can drag around, right? And it depends what your needs are. Sometimes that's enough, right? Sometimes I can just plop that here, make sure, take a front view, make sure it looks about even and leave it there. Chances are I don't need to move it. Again, if you're like working with engineers or this is like what I would call concept CAD. It's just like an idea. It's kind of rough. It's not fully fleshed out. If it's more like production CAD, you might have a mounting hole. In that case, you have points to like mount to it. The thing that I glossed over last time was inserting the knobs into our assembly. So again, just as a recap, if you want to put in a new component, you go Insert Component. You can either build a part into the assembly, which is what we did last time, or you can click on Existing Part Assembly. And so here in this instance, here's the knob that we built last time. I can double click on that. Sometimes if you have open documents already, they'll be in this list. If I don't have any other open documents right now, so I had to double click on this for this to appear here. And now if I start to like click around in here, it'll put the knob in. If I go, I forgot to do this. Open this knob again. SolidWorks has this little pin icon. I haven't talked about this before. If you click it, it means, you can see that the highlight there says keep visible. So this is like if you want to put multiple knobs in here. So if I click, this should stay up and I can keep clicking. And that's a quick way to add a bunch of parts to your assembly. So the difference is clicking that pin. And now we'll see there's all these knobs here that have been inserted. But I don't need all these. I'm going to highlight them and just delete them out of my assembly. Yes. Yes. Good question. So let's look at it. It should, when you click the check mark, what it means is it typically aligns the part with the origin and the planes. So like when I can show you that by creating a new assembly, it'll do it for sure there. So you create a new assembly, it says, hey, what do you want to start with? And so I don't want to put you can put an assembly in an assembly, by the way. Have an assembly inception if you want. So here I'm going to double click microwave 1. And now you can see when I hover here, there's like a little yellow Tetris piece. That means it's going to place the part. If I just click this check mark, what it should do is 0 the front plane to the front plane. So this is the front plane of the part, this is the front plane of the assembly. The top to the top, and the right to the right. So now let's look at it. I'm going to go Insert Component, Existing Part Assembly. I'm going to browse for my handle this time. This is what we did in class last time. Click Open. It's now here. We're going to click the check mark. And now let's see what happened here. I'm pretty sure it should be front plane to front plane. Yep. Top plane to top plane. So that's the difference. When you click the check mark, it zeroes it on the origin of the assembly. It aligns everything. Now the question I have, I think this is going to, nope, it's fixed. That's the other thing that happens too. When you click the check mark, it comes in as fixed, meaning to say it is paired to the origin and it's not going to move. So you'll notice now when I grab on this handle and I try and drag it, it says the component is fixed, it cannot be moved. You can always change that by right-clicking here and clicking on float. And now I can drag this around. Fixed is like the anchor from the sketch. That's the equivalent. There's a lot of like equivalencies in SolidWorks. Just like there's relationships for lines and points in a sketch, there's relationships for parts in an assembly. And they all kind of mean, tangent, concentric, all that stuff. Fixed, again, like the anchor. Does that answer your question? All right. So the way that I tend to work, whenever I put the first part in there, I drop it in and I click the checkbox. If I put in a new part, I tend to just click in the white space. Now the interesting thing is because we built this knob to match, we built it to match the other microwave. It's not going to work on this one. But because we built it to match the microwave, remember when we built a new part in the assembly, it aligned it to the origin, actually to my disdain. I was not happy with that from my personal workflow. But if I were to then drop that part into an assembly, because it was built off that assembly and the origin's aligned, if I click the check mark, it'll drop it right where we had it. That's for what that's worth. Okay, so I have two knobs in here. We want to talk about the relationships that we want the knobs to have to this microwave. So the first one is similar to the handle where I select this face. There's two different ways, just like like all the other features, there's different ways to approach it. I always approach it different ways. I think typically what I'll do is I'll select the two things that I want to have a relationship. So in this instance, I want this back face to have a relationship to this face here. And I select both by holding Control. They're both highlighted. And now if I click the paperclip, they're going to snap together. And SolidWorks is smart. It says, hey, it looks like you probably want to make these coincident. Now there's different options here. Parallel just means that they're facing the same way. So if the knob were rotated at like a 90 degree to that face, like here, I'll give you an example. I'm going to delete this face out. I'm going to select this face here. Well, it immediately rotated it. But here I can make it parallel. So now they're facing the same way, but they're just not touching. There's always this option here, this alignment. Maybe I want the knob to be facing the other way. By clicking that, it flips it around. You guys see that? So again, you can always change your selection here. So I can delete this face out. That's what I did. And then select this face again. And now it's like way over. I don't want it to be parallel. I want it to be coincident. Some of these other features should be familiar, right? So perpendicular obviously means 90 degree relationship. Tangent is grayed out because it's not an option. They're both flat faces. If I delete this face here and select this face here, it should allow me to do tangent. Here we go. Click on tangency, select this. And now this knob, in fact, it's basically now it's going to be tangent to that face, so it can slide around it. But that's not what we want. We want this face here. Sorry. See, you'll notice it's not letting me select this face because tangency is currently selected. And again, it can't be two flats can't be tangent to each other. You need at least one curvature for there to be a tangency. So I'm going to select coincident, and I'm going to select this face again, and now we'll see what happens. And again, sometimes it might be facing the wrong way, right? Now the knob's pointing inside the microwave. We want it pointing out. Sometimes you'll want to use like distance. You can use this to like offset it. Like let's say I want it to be a millimeter off that face, just floating a bit. That's what this is for. Again, you can flip the dimension. But again, we want this to be coincident. Depending on what you have, other options may appear, but I think these are the majority of them. And of course, angles, like if you want to have it a relationship at an angle. So like maybe it's maybe you want it to be like angled 45 degrees forward. Any questions on those mate relationships there? Okay. Concentric is also grayed out because these are two flat faces. So we're going to click the checkbox. Now, once you have that mate, I can actually drag this part around. And you'll notice if I give you a top view, it'll be evident that this part can only drag left and right. I can't go front and back because those two faces are touching. So mates are really good at having bodies that move. You could mate, like if you have an object that slides, let's say you have like a pneumatic, like these chairs, you could mate the inside cylinder, or sorry, the skinny cylinder to the inside of the bigger cylinder on these chairs. And in SolidWorks, that would then slide up and down. and represent pneumatics. So the next mate we want here, again, this is the one I glossed over. It's called concentric. Concentric is the circular equivalent to parallel. So I'm going to select this outside face here, and I'm going to select this inside face here. And again, SolidWorks is smart. It knows that, hey, maybe concentric is what this human's looking for. And so now my knob is fully defined. I can't drag it out. However, the nice thing is because of the concentric mate, it can spin. There's nothing fixing it vertically. That's the relationship it has. Is it's saying, take these two circles and make them parallel. Parallel is not the right term. Concentric is the equivalent, but I think that's making a point. So you can, through the way that you mate your objects, you can make it so that things easily move and turn and change, okay? Are there any questions on any of that? Yeah. Oh, please, yeah. Yep. Yo, that's cool. I'll be honest, I've never used that one. I've kept my mates basic, not advanced. Nice, I like it. Yeah. Okay. Does it spin? It still spins. That's really cool. Nice. I like it. Yeah, that's awesome. I'm always happy for you guys to share what you have found, and we can all learn from each other. We'll come back to the handle in a minute. Another way to do this, so it is possible to also mate to edges and to planes. So there's many different things you can pick. So if I hide this one, let me put another knob in here. Let's see if this works. Another possibility is you can select an edge. So instead of selecting this face, I could select this edge here. And let's see if, no, that probably won't work. Let me see if I select this edge, what happens. So I select both and then I click the mate. So it's telling these edges to be coincident, even though, oh no, maybe they do touch, and that's why it allows that to happen. So that's another way to do it in one step, is maybe with edges, but there's a chance that, let me see if I can quickly modify this. So again, if you update your part, it should still update into your assembly. So let me just change this a little bit smaller and see if that edge mate still works. I think it should. Hopefully my model doesn't blow up on me. Nice. So that's maybe where the edge, is it overdefined? Wait, why is it overdefined? Yep, okay, the edge did fail. So that only works if the edges are either the same size or close to the same size. But the only reason I bring that up is to say that it is possible to mate with edges and not with faces. So yes, it doesn't work if it's different size. Another way to mate is with, show you one more thing here. If you go to view, so sometimes you might have something that you want to spin about a central axis, but you may not have like a space for it. For example, there may not be like this face here to select or this face here to select. In which case, once again, Mari's trick is really good because then it still has the flat face and it mates them to center. So I really like that. But for what it's worth, you can also, here in the hide show types, there's something called temporary axes. And what this does is anywhere there's a circle, it puts a dashed blue line, and that is another thing you can mate to. So here, if I just delete this, what did I do? So you go to View, Hide Show, and over here you want to depress temporary axes. And now anywhere where there's a curve, there should be a blue line. I believe also on. Okay, no, oh wait, no, I just hit. Oh, that's why it disappeared. Yeah, do you see this blue line here? This is the central axis of this curve, I think of all of these edges. I don't know if they all align. They may, I forget, to be honest. So for example, now, once again, if I go Insert, Components, Existing Part, Browse, and grab a knob here. Let's grab this one. This is one I built earlier on. You'll notice that there's a blue dashed line in here. So again, I bring this up in case you don't have exterior faces. All right, you can select this, and you can select, another axis, and you can mate them together. You'll notice here now it's way in the front. Again, though, I like what Mari showed us because that's more efficient than this one. I do believe you can also do a mate from the temporary axis to the face, for what that's worth. Let's look at what other advanced mates are in here. Profile center, symmetric. Yeah, these might be worth playing with. I'm assuming symmetric means whatever is on one side is also on the other. I guess that's literally the definition of symmetric. Ooh, path mate, that looks interesting. I wonder if that could like proliferate a bunch of, I don't know. I'd have to play around with those. I'm not familiar with them. But yeah, good find there. Yes. Yep. You literally click and drag on it. I don't know if that. Sure. I'm happy. Wait, so when you click on the knob, it doesn't move? Okay. So there is a chance. So you can always do this, right? When you go to your part, at the very top here, it says mates. Now these are the mates that are defining it. These are the relationships that part has to another part. So if the knob that you have is not rotating, chances are you probably have like 3 mates here. You might have like a mate to keep it parallel vertically or something. So I would double check on the knob that's not moving. I would like expand the part on the left by clicking this arrow. Then look at the folder that says mates and microwave assembly. Look at this and see what these say. You should have one that says coincident and one that says concentric. If you have a third one or something different, it may not. It just says in place, and it's only one mate. Okay. I'm happy to help you. I'll be honest, I'm not familiar with that term. It sounds like it's fixed. You could always like right-click on that thing that says in place and click on suppress. You know what I'm assuming? Because we built that knob into the assembly, it may be fixed. Right-click, actually, here, do this for me. If you right-click on it, see, does it say fix or does it say float? So in your tree, the knob that's not moving, if you right-click on this, see if it says fix or float. It says fix. Okay, that's interesting. If you don't mind, I'll take a deeper look when we do one-on-one, and I'll help you out. I'm not familiar with that. But you could always suppress that. You could always right-click on the thing that says in place and click on this. Again, suppress means like it's turning the switch off, and then you could redo the mates based on what I just showed you. If you suppress that, you should be able to drag and move it. And then you can do what Mari said. You can select the 2 faces, go to advanced mates, and say profile center. And that should solve your problem. Cool. Any other questions on mates? Okay, I want to show you guys one last thing on moving bodies. So you'll notice that we built our lid into here. That is one of the detriments. So again, last time we were talking about the positives and negatives of assemblies. When it comes to part strategy, and often in like designing within CAD, just doing a concept in CAD, it makes sense for everything to be in the same part. It just keeps things from getting lost, from things from being overly complicated. The assembly is good when you're sharing files or using the same part over and over again, or using an existing part that the client has. But the assembly is also good if you need moving parts. So like, let's say you are trying to set up a rendering and you want to rotate that knob or show open and closed views. Assemblies can be slightly better at that. A workaround in a part, so I don't know if everyone wants to do this. We can, in your assembly, if you just right click on the microwave body and say click on open. This is not a requirement for project 2. This is just, I wanted to show you guys. You should have something up here that looks like two wavy lines, two wavy pieces of paper, a white one and a blue one with two arrows. It says move copy bodies. If you click on that, it'll start a new feature dialog. And so firstly, it's asking, hey, what bodies do you want to move? So in this instance, let's say I want to open the door. I might select both the door and the glass itself, okay? Now, it defaults to translate. If I just like type in like 10 inches here, you'll see the yellow shows the door moving up 10 inches. Maybe that's great if my concept is a door that slides up and down. Obviously, more typically, this would probably be a rotation. So this is where I would drop down this menu here. So here with rotate, either I could just type in a value. So again, on the y-axis, which is vertical, I could type in 45. And you can see it moves this door about its center. But the way that I like to use rotation is with this feature here, where it's saying, this is allowing me to select an edge for it to rotate about. So here's another instance. If I wanted to do this properly, I would look at that microwave door. I would try and judge roughly where the pivot is for the door. From a top view, I would guess that that pivot would be centralized here somewhere. I could extrude cut a hole through there and use a temporary axis to pivot around that axis. If I'm feeling lazy and I'm just trying to get a rendering and I don't think the client's going to notice if this is a little off center, I can just like select this edge here. But again, for this class purpose, if you guys want to do that, you can select this outside edge. And you'll notice all the options disappeared on the left here. Now there's an angle of degree. And now as I hold on these arrows, I can move this door a calculated degree amount. So let's say I want to open 30 degrees. The last thing to notice is there is a checkbox up here that says copy. Again, sometimes this is useful. Sometimes you want to copy parts within your file and have multiple things that look like they're fanning out. That's maybe when I would leave copy checked. In this instance, I just want to mimic the door opening. So I'm going to uncheck copy so that the old door disappears. Everyone have something like this? And now if I click my checkbox, now I have my microwave door partially open. You'll notice if we go back to the assembly, it's going to ask if you want to update it. You can click yes. This is where the handle being mated left to right is a little bit more, and top to bottom is a little bit more important, because you'll notice it moved over to the side here. So again, this is just like with the master sketches where you anticipate the changes you know you need to make. Just like I said, it's not necessarily wrong for a sketch to be blue. It doesn't always matter. It doesn't have to be fully defined. However, if you're trying to move something and you don't want that sketch to jump all over the place, that's when you want to define where it is in relationship. So let's say I know my client is going to want an open and closed view, or maybe I want to show my client an open and closed view. That's when it might make sense to take this handle and define it more. So Mara, you mentioned you had trouble fixing your handle. So let's look at this. So right now we have this face here stuck to this face here. That's the only mate we have. If I want to fix it left to right, I could. My default, honestly, if I wasn't thinking this through too thoroughly, is I might take the right plane on the handle and the right plane in the assembly and fix those to each other. But you'll notice now with the door open, that probably wouldn't be a good thing, because now it would be fighting. It would actually give me an error. The error would be because the right planes are at an angle, but these two faces that are stuck together are not. So, but I'll give you a clue. The right plane is the key to the left-right mate. Do you guys see what we could maybe mate the right plane to keep this locked on the door where we wanted it? Let me rephrase the question. So what do we want the handle to be in relationship to? The microwave or the door? Right. So now if that's your thought process, okay, what do I want this part to have a relationship with? In this case, the handle's on the door. So if the door opens, we want it to be related to the door. So now we look for similarities. So okay, the handle is very organic. There's only one flat face, and we've already used that. So, but however, we have planes that are flat. So now the observation is, okay, we have a right plane. What is the most similar plane on the door to this right plane? I'll give you a hint. There's 4 of them. Yeah, there's this face in here on the glass. However, a better face for me is this face out here because it's easier for me to select. It's parallel to the right plane. So I can select these 2 things, the face on the door and the right plane on the handle, and I can click mate. I can click the paperclip. And now again, SolidWorks, it defaults to coincident. But obviously we don't want that, do we? We want it to be offset slightly. And so that's where we would use here the distance tool. And now I can dial in whatever I want this distance to be. Yes, I think I understand what you're asking. So the fillet, so when you, okay, let's look at this. I'm going to X out. I think what you're zeroing in on is you're noticing that this side face is actually set back a bit because of the fillet. So here's how SolidWorks is thinking, okay? So firstly, you're talking about the handle going into the door. It's not going to do that because this face and this face have been told to touch each other. So it's not going to go off of it in any direction. They're going to stay concentric. In this instance, this face and the right plane have nothing to do with the front backness of the handle. All it has to do is with the left rightness of the handle. Does that make sense? So what we're doing is so SolidWorks, it doesn't care about anything else in this instance. It's only looking at the right plane in relationship to this flat face on the side. So what we're doing is I'm saying, the first thing SolidWorks says is, hey, do you want these to touch? And I'm saying, you know what? No, I don't want them to touch. I actually want them to be offset from each other because I don't want that handle to be on the edge of the door, centered on the edge of the door. I want it to be inside a little bit. So here I can type in, whatever value I want and say, so it's not moving the handle in because that flat face is already touching the front of the door. It's only talking about a relationship from the left-right of these 2 parallel faces. And again, I'm referring to the plane as a face. It's not actually a face, but it's operating as if it were. It's like a flat plane. It's a sheet of paper that I'm telling to be parallel to this face on the door edge. And not only parallel, I'm telling it to be exactly an exact distance of parallel and an exact distance. Yes. Okay. Yep. 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 So that's down here, mate alignment. So, which I agree is confusing. You would think SolidWorks would be smart enough, because you can put in negative degrees and negative measurements. SolidWorks does some weird stuff sometimes. They decided here it's going to be mate alignment. So if you click on this, you'll know it should flip my handle. Did it not? Oh, it's rotating mine. Here we go, flip dimension. I'm sorry. Try this. Do you have a box that says flip dimension? My mistake. And again, when there's one-on-one, I'm happy to help you guys with these nuances. Flip dimension works? Okay, cool. My mistake, guys. It looks like mate alignment rotates the handle. That makes sense because, let's see. Here's the best way to explain it. Let's see this X, right? This is my middle plane. And right now I'm saying there's an X on this side, not on this side. So the side with the X, this is my middle plane on my handle. I'm saying I want this to be parallel to my hand. If I click on the flip mate alignment, it's taking this plane and flipping it like this. So now the X is facing that way. That's what it's doing. So that's why the handle, it's when I check this, it rotates. That's why the handle rotates 180. Is because this face is defined, so the handle's going from this to this. That's what's happening. So they have flip dimension here. I don't know why they don't have negatives in there. I agree that's confusing, but that's why that's there. Okay. So actually, I'm not happy with this value. Let's see, can I click on this and reopen it? Yes, I can. I want this to be in just a little bit further. I want this to be, let's see, 20 millimeters is where I want it. Now you can click check, the mate dialog stays up. Any thoughts on how we did that, based on how we did that, how we can let me back up. So now we have the left-right figured out and the front-back figured out. What's the last one that we need to figure out? Top-down, correct. Now based on how we did that, anyone want to verbalize or suggest how we might now mate top and down? And again, you can always figure out what's not mated by dragging. Seeing. Yep, exactly. Okay. I know I'm asking obvious questions. I just wanted to make a point. It's a good answer. Yes, we can take the top plane of the handle, or no, in this instance, it's the front plane because of the way that I built mine. I don't know how you guys, I think this is the one we built in class. No, it's not. So in my instance, it's the front plane. So find whatever plane is parallel to the top face of the door. However, this doesn't matter as much. You could actually mate this to the top of the microwave or to the, I don't know, because the door doesn't move up and down. It's only pivoting. So that right plane was the main critical one. But to stay with the analogy, you always want to mate it to whatever it has its closest relationship to. So in this case, it's the door. So we can take the front plane, hold down Control, select the top of the door, select mate, and again, give it a distance. If you eyeball where you want the handle to begin with and select distance, it'll move it back to wherever it was when you click check. That was like kind of a confusing sentence. I hope that made sense. So like, let's say I start with the handle just by dragging it and placing it exactly where I want it. When I do those mates, it'll snap to coincident. But then if I check the distance mark, it's going to move it back to where it was at the start of the mate dialog. So now with this checked, I can now, in my file here, if I go back to my microwave, my move body command's at the very bottom. Again, another general tree organization thing to put if you have moving parts and bodies within your part. It's best to do it towards the end because now I can right click on this and suppress it. And now the handle snaps back with the door. Does that make sense? For what it's worth, again, I tend to work in parts. It has to be a pretty complex assembly for it to be worth it for me to go into an assembly just to make things move. If I'm rotating a knob for a rendering, I'm just going to do that as a move body command in SolidWorks. There is also like a little bit of frustration for me personally that like this is kind of imprecise. I like to dial in the exact degrees that I have things rotated. It is possible to do a mate at a degree relationship. So for example, I could take the right plane in this knob and mate it to the right plane in the assembly and give it a degree relationship. So I'll just show you what that means. So I can take the right plane in the knob here, the right plane here, I can select mate, and now this is going to be vertical, or I can take a degree and say, you know what, I want this to be exactly at 15 degrees. So like, I'm complaining that, it's somewhat imprecise, but it is possible to make it precise if I wanted to take that time. Cool. Any questions on anything? All right. So let's see. We are now going to get into drawings here. I'm going to zero this out. Okay, so everyone should have an assembly with a handle and two knobs in it. I'm assuming everyone has a microwave. I do have a plate in here. I'll upload this to Box so you guys can drop that in if you want it. It adds a little bit more realism to your microwave, and it's one less thing you guys have to build. But for what we're doing now, that's not important. So we're going to make a drawing just like we did for the bottle. So let's recap on that. So we go to File, New. and you just want to go over here to drawing and select OK. So now with this dialog box, I like to go to custom sheet size. I'll leave it up to you guys. You can either do 8.5 by 11 or 11 by 17. I don't mind. I'm going to do mine 11 by 17. So here for width, you'll notice mine defaulted to millimeters. Your guys' drawing might have as well. So I might type in 17 IN to make sure that it's inches, and then 11 IN for height. So again, if you want to do 8.5 by 11, you could do 11 here and 8.5 here. You are printing this, by the way, so if that sways your decision. And then, yeah, click that check mark. And so now you should have a blue piece of paper. Does everyone have something like this? And again, this should be a recap. So hopefully this isn't like, oh my God, what are we doing? Okay, then the thing on the right here, it says, what do you want to drop in here? So what we're going to do is you're going to select your assembly. I'm going to double click on that and come over here. Now, what we're doing differently this time from before is we're making a full orthographic sheet. So I think everyone's view defaults to the front view. You should, when you hover over the blue or this gray blue area, you should have a box. Does everyone have that? So what you do here is you click, and it should put a front view of your microwave. Now just click once. You'll notice, hopefully this is working for everybody. If it's not, I can show you how to fix it. But if you drag up and to the right, you should see a right view appear and a top view appear. Is that working for everybody? So everyone should have a top view. You can click, and then you can go back down here and drag to the right and have a right view. If you wanted, you could keep going. You can even go diagonally and have an isometric. But for project 2, the only requirement is front, top, and side. SolidWorks is really nice at making like easy orthographic drawings. But once you have these 3 views, you can click escape or check, and you should have these. You'll notice they're kind of tiny. If you click on the front view, which is the main one, you can go, it brings up this, this property dialog box. You can scroll down here and you can change the scale. So it's defaulted to use sheet scale. You can click on use custom scale. And here, I typically like to do user defined. Again, if you're working with engineers, they may want a very specific scale. I do user defined because I want to get like a size that's like good on the piece of paper. You'll notice if you change 1, all of them change. So for my microwave, 1 to 3 is a little bit too big, so I'm going to try 1 to 4 to just shrink it a bit. 1 to 4 seems like a good size. Everyone's microwaves may be slightly different. I don't know. You can pick whatever size works for you. And again, you can always if you hover over this, you should see like an orange box. You can drag this around. You'll see that they always stay oriented to each other. I don't know if you guys remember doing orthographics in like DES 140 or 240, but this makes it way easier. There's no mistakes here. I'm going to assume also, and this happened on the water bottle, it wasn't a big deal. And actually for grading, it made some things kind of somewhat easier. For this project though, I want to turn off all these sketches. You'll notice, at least on mine, if I zoom in here, you'll see all these dots. If you just hit Alt-V with my hotkeys, that'll turn sketches off, or you could go to View, Hide Show, and just turn off all the lights, or all those buttons with one switch. So everyone should have something that looks roughly like this. Quick sidebar on orthographics. This is the American standard. The Chinese standard is opposite. In the Chinese standard, this handle would be on the top. This handle would be on the right. They invert it. I think both are used equally. I prefer the American version. It makes more sense to me. It's like the handle is facing the handle in all the views. Okay, the next thing that's a requirement for project 2 is to put dimensions on these. So you can do this one of 2 ways. If you have my hotkeys, you can hit the letter D for dog, or you can go up here and click on Smart Dimension, either way. And what I'm looking for is just at the bare minimum, the overall dimensions. And so here you'll notice it's just like a sketch. You can select edges. And in a drawing, it's smart. It's not, these dimensions are driven. The object is telling the numbers what to be, not the other way around. So in a sketch, the numbers are telling the object what to be. In a drawing, the object is telling the numbers what to be. Did I say that right? Did I mix that up? Okay. It's defaulted to metric. That's fine. It doesn't matter what you guys have. I mean, I'm just going to switch mine to inches, but and show you guys how to do that if you want to. You don't have to, though. You go to the gear, you go to document properties, units, inch pound. Click on check. Okay. And now that updates. I'm going to show you guys the bare minimum, but I want to add in another thing. So we have the height here. Maybe we want to show the width here. It doesn't really matter which ones you pick. So here I'm going to pick the far right edge. If you have a fillet, make sure you don't actually accidentally select the inner one. Make sure you get the widest edge. So I'm going to select that edge, zoom in and select, and it gives me what that edge length is, but until I select this other edge here, now it gives me that width. You can always hit escape, get out of the dialog. And so now on this one's a little bit trickier. If we're getting the overall dimension, right, technically we should go to this widest part with the handle. And you'll notice there's nowhere for me to grab here. So one thing you could do is you should see a sketch dialog at the top here. You can select a point. And now if I hover over here, it should give me a center point to snap to. I don't think it gives me that with a dimension. Yeah, for sure. So you'll notice with the dimension, there's nowhere to snap to on the arc. So I'm going to go up to my top here and look. This is just like the same sketch tools we have in SolidWorks. I'm going to select this one, which is a point. Now if I hover over this arc, it gives me a central point to snap to. And you can then click and get a point there. And now when I do a dimension, I can dimension from this point to this back edge. Again, if you have a really small fillet, make sure you get the widest edge. And then go off to the side here. So this one, because it's going to a point, I believe that's why I'm getting this dialog box. And you can just say, make this dimension driven and click OK, because it's going to a sketched part. So that's the bare minimum, is the overall width, the overall height, the overall depth, okay? However, I would recommend just for your own practice and getting used to these things to maybe add one or two more so we can do those together now. It's not hard. And this is also just a chance for me to teach you guys basic dimensioning. Great question. So in terms of like whether I'm going left or right. So there are some general rules of thumb. Sometimes the place you're working for, they'll tell you exactly what they want. General rule of thumb is to go to the outside of the page. If you go to the inside of the page, like dimensions in here, it starts to get like, especially if I'm having dimensions coming off the front face on this top view. Like let's say for whatever reason, I wanted to dimension this handle. It's not letting me. I'm just gonna grab this point here. Sometimes you have to add sketches to this to help you out. But let's say I want to do this. Like this is where there's like confusion, right? Because they're both going to the center here. So there's some general rules of thumb. The first rule is to, actually I should have left that on there. More important than going to the outside of the page, put this back in. The first rule is to always avoid crossing the object when you can. That is a very bad dimension that I just put in. Never do that. Sometimes it's unavoidable. Sometimes you have to cross the object. But when impossible, avoid crossing the object. I would say that's like the biggest rule. Reasoning for that is now like, obviously this is a different color, it's gray. But I don't know, it adds confusion, especially if you have a ton of dimensions. Like line edges and dimension lines start to blur together. So that's the first rule. Second rule, in general, you just kind of want to stay away from the other views. So that's why it makes sense to go to the edge of the page. Here's another rule. So I'm going to add another one here. All right, we'll leave that for now. That's a weird dimension too. I don't like that one. Because I'm going to the inside of the handle, the width of the handle would make more sense. Another good dimension would be the width of the microwave without the handle, right? Because the handle's kind of protruding. This dimension here, here's another no-no. Never do this. Just like you don't want to cross the object, you don't want to cross dimension lines. So that means the widest dimension is always the furthest out. and all the skinnier dimensions stack getting shorter and shorter on the inside. Now you'll notice, for example, these dimensions here on this view, this Z dimension, the depth, I could totally provide them on this view as well, right? Yeah, good question. From an aesthetic standpoint, there is kind of like, which I know sounds silly, but aesthetics in the sense that you want your drawing to be very easy to understand, and everything should like look nice and pretty in a line. Which view is best? It doesn't, when it comes to this top view versus this side view, it doesn't matter, honestly. It comes down to where there's space on the page and personal preference. I do believe it is standard to try and group the dimensions as much as possible to one drawing. So, for example, this being the main view, the front view here, I think it would be more typical to put both the width and the height on the front view, because this drawing has the most information. So I'd go to the bottom of the feet here, and I would also probably give, for my client, this dimension here. I don't know, maybe they want to know how big the window is. So here's an instance where it's impossible for me to avoid crossing the object. I have to give them that window. And you'll see how my dimensions, they get smaller as they get closer to the object. I also try and align the numbers so it's like easier to read. Sometimes that's like, I don't know, that may change if like the dimensions get really close. It may make sense to offset the numbers, but I tend to align them again just for a visual purpose. I may want to give the overall size of the door. So again, I go from the width here to the edge of the door here. And again, I align this. This would be more typical of a dimension drawing. So it's like all the information is collected. There's really not a lot of new information given to us here. A dimension that would make more sense on this top view versus this front view, I would argue would be like the knob. The reason for that is if I want to show what the knob standoff is. So again, here I'm going to the inside of the page because I don't want to cross over the handle. So that's my rule of thumb here. That knob dimension to me is a lot more, the name of the game in dimensioning is clarity. You're trying to be as clear in your communication as possible. Here we have a clearer view of what the knob looks like stood off the front. Here it's a little more muddy because the handle's behind it. So that's another way you might make that decision. Does answer your questions? Here's another like incredibly nuanced thing when it comes to working with engineers or doing dimension drawings. So the reason you might do drawings is, let's say you're doing a Kickstarter, you're getting your product manufactured overseas, somewhere, even locally. By doing a drawing, you are setting a tolerance. It's kind of they're called control drawings. Okay, so like. Sorry, they serve several functions. One of them is to say, hey, this is the dimensions I want my object to have. And then your supplier or your manufacturer may then look at that blueprint, and that's how they're going to manufacture the part. The other reason to use it, and how things are going in the modern era, is like the part can be manufactured from a CAD file. So but you would still do a drawing, and that would be used for what's called a control. The drawing is essentially a contract that you make with your supplier to say, hey, if these dimensions are off, I won't accept the part. And when you get into that nuance, these dimensions, you have what's called a tolerance level. So you may say, I will accept any microwave that is that is 13 inches tall plus or minus 0.01 inches, right? Because there's slight imperfections in manufacturing. So you have a tolerance. The drawing is used like a contract to make an agreement. Therefore, and that's why that's how engineers, for example, they decide how big to make this gap, is they test what the tolerance is. So if the door is at its biggest size or most, let me give a different example. So like on a bicycle wheel, right? If you have a bicycle wheel inside the frame or the fork, there is a certain amount of gap between that wheel and the fork. If that wheel isn't manufactured properly, maybe it's a little off center, you don't want that tire to rub on the edge of the fork. So there is a tolerance of acceptable slop, so to speak, where the wheel will still function as intended, and then there reaches a point where the rubber starts to rub on the edge. So here with the door, depending on how the door is mounted and stuff, it may be like 0.05 inches to the right. At what point does that door start hitting that edge? That's how they determine the tolerance so that door still functions. We're getting in the weeds now, but it's a long way to say that's why we do these drawings. That's one reason for them is for sort of a contract of what's acceptable, what's not acceptable. Any questions on any of that? Okay, as long as you have this and print it out, that is one of your requirements for project 2. Again, as long as you have the overall dimensions, so overall width, overall height, overall depth. For what it's worth, if I got this, I would mark it wrong because it's missing the depth of the handle here. It's not the overall depth, it's just the depth of the microwave. If you followed the first 3 things I did, you're good. Yep. Yep. I'm about to add it in. So put it in here. Sorry, that's what you're going to ask? Was. Oh. I hear you. Let's talk about that. That's a good question. So let me show you. I was just saying my requirements for project 2 is overall height, width, depth. And my nitpick here to kind of help you guys with your grade is, darn it, I keep hitting escape. Is to say, hey, if you guys had, you're missing your overall depth here. That's the issue. Oh, let me mention 2 more nuanced things. One is, so here again, it's good to align, like trying to align these views. And again, it's just for clarity, and SolidWorks will snap them. So this like arrow is aligned to here. Okay, so Mari asked about the depth of the handle. I could have done this measurement here. Instead of the overall wide one. Again, we're in the weeds, but I'm going to mention this because it is important, especially if you are providing drawings to manufacturers or other people. Right now, technically, this is overdefined. The reason for that is this number is saying how wide this is. This is saying the overall width. This is saying how wide the microwave is without the standoffs. This is saying how deep the handle is. The reason it's overdefined is now I have 2 numbers. And again, this is in the weeds and this is nuanced, but I have 2 numbers that are saying what the overall width is. It's 1.8 plus 16.5 and 13.3. And of course, 1.8 plus 16.5 equals 18.3. So everything aligns. But what a supplier or a manufacturer wants to know is what is the most important number. So in a situation like this, and of course now I'm blanking on it, I think it's REF. You might add a notation that says ref. And that means that what you're telling the supplier here is that the 18.3 number is the most important number. 1.8 is just for their reference. Again, there's not an issue here because the math works out, everything aligns. When you have a really complex part and you're putting stuff, sometimes there's going to be a slight discrepancy in those numbers. You want to be clear which one is the most important one. Here's another and again, we're totally in the weeds, but I don't know, I just want to arm you guys with full knowledge. If I dimension this view here, front to back, this is also repetitive. The 16.5 here is also down here. And again, it's all in the name of clarity. It's all to just let whoever's looking at this know this is the most important dimension. And when there's too much information or, God forbid, conflicting information, that's when you have a problem. So if you start with best practices and know to not by giving too much information, there could be a chance for conflicting information. So to know to avoid that, or to write ref if you have a double dimension, just kind of it's best practice. Again, for this project, you don't need to worry about it as long as you give me a front, top, side view with overall width, overall depth, overall height. You get good grades on that portion of the project. Any other questions? All right. So here for me, I'm just going to save this. It's going to ask me, do I want to save my assembly? And I'm just going to click yes. This is also like an InDesign file in that it's now pointing to the assembly. You can print directly from here, but again, we talked about this last time, but let's talk about it again. If you want to save it as a drawing or PDF to print from that instead of directly from SolidWorks, when you go to the Save As dialog, I think I would recommend PDF, but if you want to do JPEG, that's fine. Just click on Options and just double check. Just double check that the DPI is good. Right here, it's telling me the shaded DPI would be 96. There's nothing shaded here, but make sure that's like at least 200, I would say. Based on that pop-up, you can, I want line work for this, just because it's going to look cleaner, it's more typical. You can go here and change the display state. I could change this to be filled in if I wanted. But really what's typical is just this typical line work here, what it defaults to, the middle one. Same thing if you go to File, Save As. For JPEG, look at the options. And just make sure you're doing print capture, not screen capture. This does not have to be full scale, so you don't need to worry about scaling on a printer or whatever in this instance. The model had to be full scale, this doesn't. Okay, that for me covers drawings. That's one of the requirements. Are there any questions on drawings? I am going to take 2 minutes, 5 minutes, 10 minutes, I don't know, to introduce KeyShot, just so anyone who feels good with their CAD model, good with their drawing, they can start playing in it. Again, though, we're going to get more in depth into it. I think